Point sources. Point sources are more complicated to enter into TEISS, and it makes sense. They require more information associated with them. And not every reservation has even one point source to include in an emissions inventory. Point sources are more problematic, but it also might be that you can already have information about point sources from another place, like a permit application, and then in that case it's not so difficult. So obviously, those of you who have large Title V sources should inventory them as point sources. And again, that won't be so difficult. It'll be a lot of information, but the information will be available. You won't have to track it down for sure with the Title V source. For smaller sources, the first thing you need to do is research your state emissions inventory thresholds for the definitions. That is oftentimes what makes you decide to treat something as a point source or as a non-point source. One thing to be aware of, yes, it's a lot easier to group, for example, gas stations together as a collective non-point source, but if you want to see it on your map, the non-point sources are grouped together. So if your emissions inventory area is your tribe, you're just going to have one big color over all your tribe representing that particular non-point source. So it isn't as fun in terms of the map and the location. The other issue, of course, is that the emissions are lumped together. So if you have a source and you want to see just those emissions, then you need to set it up as a point source. And again, the point sources do require more data entry. EPA needs these discrete pieces of information for every point source. So it's easier to think about point sources as a facility, and you've got release points. So one of the release point is probably always going to be fugitive. Hopefully they will not have much fugitive releases, but then you're going to have stacks. You're going to have places where the intention is for the emissions to be emitted from a release point. So think of those as smokestacks. Then you're going to have an emission unit. One way of thinking about this as the emission unit is it's sort of like what is happening at that point. So in terms of like a sawmill, you're going to have various things going on at a sawmill. You're going to have like a grinder area, you're going to have a chipper area, you're going to have a debarker area, and those can be treated as separate emission units, and that is hopefully already taken into account by the facility from which you're going to get the data. It's not like you're going to have to go out and inspect and say, okay, I'm going to call this an emission unit and that an emission unit. For point sources that have already perhaps emissions estimated, this stuff is going to be set. So associated with the emission unit is the control equipment. So a lot of times they've got just some sort of filter. So they've got a bag house, which is a structure where they've got giant filters that look like bags. And there may also be no control equipment. For example, fugitive releases isn't going to have any control equipment. Then you're going to have the process. And the process is really key because that is actually what is happening at that emission unit. One thing that looks weird is these words, release point apportionment. That's like 85% of the emissions come through this process, or 5% of the emissions come through this process. For example, like fugitive releases, hopefully isn't that much. And sometimes there's nothing. It's like 100% comes out of this process. We don't have any different routes for the emissions. And then process control equipment, oftentimes that doesn't exist. So internal to that thing, like the debarker, they may have something that tries to control all the sawdust that flies out of it. And then, of course, the reporting period, and usually everybody treats that as annual. And then within the reporting period, finally, you've got the actual emissions. So this is sort of the structure for point sources. So let's talk about release points. And this is where the stuff goes out into the air. So there could be a vent, it could be a stack. There are often multiple release points at a facility. A lot of the facilities that I've looked at just have one release point plus fugitive releases as another. It is required as one of the components of the point source data that you have a release point type. So if you have a stack, for example, that's clearly not fugitive. But if you have any kind of release point type other than fugitive, then you have to say, okay, well, what is it? Because obviously if it's a really, really tall smokestack, that makes a difference both for how much gets emitted because stuff happens in the smokestack on its way out. Kind of like if you think about PM 2.5 can turn back and forth from a gas to a solid, stuff like that. So it makes a big difference, the height of the stack. Also the exit gas temperature, the same kind of thing. For pollutants that, depending upon the temperature and pressure, they could either be a gas or a solid. That makes a big difference. So again, if you have a release point type that's a stack, these other pieces of information are required. And default information is available. We can look at other sources to say like, well, how high is the stack? 10 feet? I don't know. So, if you don't have this information for point sources that you want to enter into TEISS, talk to us because we could probably find out something that's reasonable. Because remember, all of this are just estimates. Emission unit. So that's like, usually it's a thing. So it's a storage tank, it's a boiler, it's a storage pile, like at a sawmill or even a quarry, you're going to have storage piles. And stuff comes out of that, right? So that is its own emission unit. And usually there are multiple emission units at a facility. So again, you're probably always going to have some emission unit plus fugitive. And then the process is actually what is happening. So that is the thing that's happening at that pile or whatever it is you're looking at. So for example, the process is going to be filling up that tank at an underground storage tank. The process is going to be burning the oil at a boiler. The process is going to be handling the material at a quarry where you've got a giant gravel pile. Each emission unit must have at least one process because otherwise nothing's happening there. So hopefully nothing's being emitted. And there can be multiple processes at an emission unit. And this is particularly important for gas stations. The reason that the process is important to get right is because that determines the SEC. So the SEC defines what the process is happening at that emission unit. Control equipment, these are things that we wish we had more of. So things to control emissions. You can have control equipment at the emission unit, or you can have control equipment at the process, which sort of makes sense because for like an emission unit that has multiple processes, you may have separate control equipment to, like if you have like a sawmill where you've got one room and you've got debarking and you've got sawdust making there, you may have separate processes at that same emission unit. But you can't have both control equipment at the emission unit level and at the process because that would be like double counting the reduction in emissions. There are control equipment that a lot of times people have control equipment that isn't working. So you don't necessarily have to report control equipment unless you have the information and you know that they're working. So you have three elements to control equipment. You have control approach. So like for a bag house, that's a filter. Basically, that's what the approach is that we're going to filter this stuff out. You've got a control measure, which is like, okay, the measure that we're taking, it's so non-intuitive because it doesn't mean you're measuring something. It means like our action, our act. Like the measure we're taking is we're going to put this giant filter over the hole that this stuff comes out of. And then the control pollutant, because obviously if you have a bag house with the filter, it's not going to control gases. The gases are going to go right through that filter. It's going to control particulates. Now, if the filter is thick enough, it may be able to control gases and reduce gases just by the time it takes to go through the filter. But generally, control equipment is very specifically designed to control certain pollutants, hopefully the worst ones like lead. Release point apportionment. So this is that proportion. So, for example, if you have multiple processes, what release point does each process emit to? Because you're probably going to have fugitive plus a stack, for example. And then sometimes you're just going to have to estimate, okay, 10% fugitive, 90% stack. Hopefully the point source has already estimated that. Every process must have a release point apportionment because it makes a difference to how much is emitted and what kinds to where it comes out of. Like if it goes out a really, really tall stack, that makes a difference in terms of what actually gets out into the air. So if you have a process that's connected to multiple release points, just report the average emissions, the percentage that goes into each. So this is an example. 10% go out the vent, 90% go out the stack. Don't get hung up on getting this exactly perfectly right. This is all estimates, and nobody really knows exactly how much is coming out unless they measured every single bit of air coming out of everywhere all the time. Reporting period. Okay, this is something that we can all understand intuitively, and that's the time period. So the default is annual, and every process must have a reporting period. And that makes sense because some processes don't work the whole year. However, we have to make sure that we have an annual emissions inventory so that it makes it easier to report this data to the NEI. So the throughput, this is where the throughput, which is optional for point sources, is reported. And I don't know about you guys, but whenever I see this word optional, I'm like, I breathe a sigh of relief because that means maybe I don't have to find out that answer and import it. Okay, so emissions. This is what we're all after. How much of each pollutant was emitted by this process? If you use a TEISS calculator, this area is populated, and Angelique will show you how that looks, which is great. So as you're going through and entering the information, the actual emissions are going to be written in by TEISS once you use the TEISS calculator. However, if you have a facility that is paying fees in order to pollute the environment, they already have information associated with that permit, and that dictates how much money they have to pay. So they've probably done a really good job of estimating their emissions. And so the actual emissions fields, you can enter them also if you have information. And generally their information, we hope, is going to be better than our calculations done with our simple calculators. So this is what I was talking about, the facility tree. So you could see that this is a facility. It's got release points. You got a release point here from a process, and some of the process is going out of this release point. So this is where we have to say, okay, 90% or whatever percent is coming out of this release point. You've got a unit control approach. So right here, you've got an emission unit that actually has a filter or something on it to reduce the emissions. Then you've got, for example, on this side, you've got it directly from the process, the reporting period, and finally, estimated emissions. If you've got an emission unit that has this control approach, then you've got a control measure, like whatever it is, like filtering, for example. Then you've got the pollutant, so what pollutant is being controlled, and this information has to appear in this kind of order in TEISS, which is why this facility tree is in the slides. So this looks really complicated, but it's probably a lot simpler for the point sources that you are going to be inventorying. Only if control mechanisms are in place. Obviously, if you've got, like, oh yeah, we've got a bag house, but we haven't used it in 20 years, then you don't need this information. If control mechanisms are in place, then you do need this information. Whoa! This is another process flow diagram that actually came from Minnesota, and this is for a fiberglass boat building facility. Obviously something there's probably a lot of in Minnesota and not too many in Arizona. So what they do to make these fiberglass boats is they have these things called molders, and they mold, I assume, the various parts of the boat. So you've got what are called molder lines. So, and including other things that we can more easily imagine, like a sawdust pile. But this is a typical sort of diagram that you might see if you get information from your point source. First thing I do whenever I'm confronted by something like this, I Google it. And a lot of times you can find the information, okay, so for a boat building facility, what do they do? How to just to make sense of these terms. Some of them are pretty straightforward, like sander, but this is actually what happens at this facility, and you need to at least be able to put some of this into context so that you can enter it into TEISS. The first thing to do is figure out what the words mean, and you can see in this particular diagram, you've got release point prefixes. It's not necessary that you understand every little thing, just you understand in general what's happening so that you can get to the right SEC codes, because those are critical. Obviously, EU is Emission Unit, and even at this facility, it gets cold in Minnesota, so they've got a boiler, so they've got things that aren't even related to what they're making at this facility that has to be incorporated into the emissions that are coming from here. This is just one part of this, the molder line where they mold the fiberglass for the different parts of the boat. And so Angelique is going to demonstrate, okay, just looking at this one part of this point source, how do we enter this information into TEISS?